We're going to be talking about using PetSet to automate PostgreSQL. This is mainly, about how PetSet solved a whole bunch of problems for us in doing containerized databases. For anybody, was anybody here at my presentation in London? So in London, I actually presented the early work in progress on this, and this is actually pretty much the completed thing. So first of all, I want to start out with a thank you to Zalando. Zalando is a mega fashion e-retailer in Europe, and they've been doing a lot of work on Patroni here and on automation and that sort of thing. So the lion's share of what I'm going to show you was done by the Zalando folks. So, talk about PetSet. Well, actually, no, we're not going to talk about PetSet. We're going to talk about stateful set. Anybody here missed the rename on that? The rename was a good idea. PetSet was a working name, and it was never supposed to be the final name. It's all about stateful containers. So how many people here know what stateful set does? Okay. And how many people here had never really heard of it before they looked at the program? Okay, everybody else is sort of in between. So I will show you a little bit of that in action. Now, the reason I got involved with Kubernetes to begin with is because I wanted to automate Postgres. That was the whole thing. I've been working on the Postgres project for 18 years, and so Kubernetes comes along, and I'm like, oh wow, a tool to solve a bunch of the automation problems that I have. But the tool wasn't quite ready to actually solve those automation problems. Now, one of the other projects I've been working on is something called Patroni. Patroni is a daemon that manages Postgres and Postgres replication and Postgres replication clusters. It's a way to automate management of Postgres replication. This is the thing the Zalando folks have put in so much work on. It's an offshoot of compose.io's thing. But the important thing for you to know is it's a daemon, and it controls Postgres. And when you're launching containerized Postgres, it runs as the primary process in the container. Which is important for automation because it means that I know that if Patroni is not running, then Postgres is not running, which eliminates a whole set of split brain cases. So, and Patroni works in production, running on Zalando and hundreds of database servers and that sort of thing, running at a few other sites, but outside of Kubernetes, not through Kubernetes. And so we actually want to automate this in Kubernetes. Now, one of the important things is that here we're talking about single master replication with Postgres, the primary way to actually have a bunch of Postgres instances, right? You've got one master, and you have 0 to many replicas. And this is still, there's more advanced clustered versions of Postgres in development, but a lot of them are fairly alpha at this point. Plus, for simple cases, single master replication is just easier to manage and easier to understand. But that means that when we're automating it, we have to play this game called Where's the Master, right? Because if we want to deploy a bunch of identical Postgres nodes and have the Postgres master just come up, and the rest become replicas of that master, then something needs to determine that. And that's actually what Patroni does. But when I was trying to automate this through Kubernetes, I ran into a number of problems doing this in Kubernetes 1.2. And I'll explain these problems in detail, but these problems basically amounted to node identity, replication connections, connections to the master, storage persistence, and shard, and now that I'm actually working on sharded Postgres, I won't be showing you a working copy of that today, but I will have one online next week. For sharded Postgres, shard identity. And these things were very hard to solve in 1.2. Now, so the first thing was node identity, and that is that if you deployed a group of Postgres instances as a replica set, then you didn't really have a good way to address them individually. And that became a real problem because you might want to say, okay, I want to load balance to replicas 1 through 5, But then replica 6 is my special reporting replica because it's going to have the month-end reports on it, and I don't want to put anything else there. And replica 7 is going to be supporting continuous backup, and so again, I don't want to put any other load on that. And there weren't any non-hackish ways to do this before stateful set, because you didn't have an address that Kubernetes understood that said, I want this particular replica. So what we would, and similar to this problem is something we call replication identity, which is that the current master needs to know the identity of all the replicas that are connected to it. Among other things, the master needs to know if replicas get out of sync, it needs to know what data it has to save for those out of sync replicas, something called replication slots, which actually has a more messy problem that I'll explain in a minute. And so we also need to, the master also needs to have an identity for each of those replicas. So the way that we tried to do this under earlier versions of Kubernetes was to just push the pod IP address. To say, okay, we've got these pod IP addresses, they're unique, you can actually connect to the individual nodes for that, and so we're going to push the pod IP addresses and use that as our de facto node identity and hang everything else off of that. Well, there are a number of problems with using the pod IP addresses. One of them was that doesn't really mesh with Kubernetes services. So it meant that we couldn't actually use Kubernetes services to funnel connections to the replicas because Kubernetes services don't pay any attention to the pod IP for a variety of reasons. But then there were also the thornier problems, right? If Kubernetes needs to migrate stuff due to resource usage, sometimes the IPs will change. If the IPs change and you've cycled through your set, IPs can get reused. There isn't really any understanding of continuity that this IP address is associated with a particular Postgres instance and its stored database. And that didn't help us to have a set connection to just the master for read-write connections. There also were some other permutations of it that were really messy to solve and required hackish things. And one of these, to give you an illustration of this, is through something called replication slots. So the idea of a replication slot in Postgres is you basically put, every time the replica slurps down new data from the master, data that's changed, table updates and inserts and that sort of thing, it puts a bookmark that tells the master where it left off in case it loses the connection. And that's important because if you do lose the connection between the replica and the master, you want it to pick up when it's left off so the master isn't saving any more data than it absolutely has to, because it can, if it saves too much, storage can really balloon. Well, the problem is that if you have a lot of sort of intermediate failures and you have replicas coming up and down all the time, some of those IP addresses are going to change. And so what happens is what was .1 goes down and it gets replaced with a new replica, but that new replica is in .3. Well, that replication slot for .1 still exists, only it's not being used. And because it's not being used, it's just accumulating data. And so if you had a series of failures that was forcing you to bring down, up and down a lot of replicas, you actually end up with a pile up of replication slots that are not consuming data and they're accumulating data on the master. And if you have a very high transaction rate, you may have very little time to react to this. And so then that forces you to have a watchdog process that looks for replication slots that are not being used anymore and deletes them, so that they're not storing up data anymore. But there's a problem with running that watchdog process. If the watchdog process reacts too fast, then the replica comes back and it can't get data anymore because its slot is gone. So not really a solvable problem in the context of Kubernetes 1.2, and I feel kind of illustrates one of the issues that we were having without stateful sets. So there were a lot of sort of workarounds in this. One was that implementing this in like 1.2, we actually ended up failing over a lot more often than we really needed to. A custom proxy for handling master, et cetera, connections was absolutely essential. Then that custom proxy actually has to read separate information that's outside of Kubernetes. Your discovery basically does not use Kubernetes discovery. You have to create headless services to front these things, and the headless services connect to pod IPs. And if anybody's done that before, you know it's a little unreliable, again, because those IPs can change around. And then a watchdog or cleanup process to actually deal with all of the sort of fallout for things that don't just work. And so it ends up being a relatively sort of complicated topology, even on a minimal thing, right? You've got to at least have, in addition to Kubernetes and a separate etcd or other DCS cluster, you have to have your Postgres instances running Patroni, you have to have a custom proxy, and you actually have to have some kind of a cleanup watchdog service in order for all of this to work. Which is messy, and what I really hated about it is it meant that most of my automating of Postgres was happening outside of Kubernetes. All the Kubernetes was doing for me was making sure that I had a certain number of Postgres containers up and running. And these other processes were up and running, but all of the other automation took place outside of Kubernetes. That was not what I wanted out of Kubernetes. I wanted Kubernetes to do the automation for me. So, there are also some other issues, storage issues, in that this was even worse and sort of fundamentally unsolvable, which is that if you wanted to have persistent volumes to store your databases, then there was no understanding that the different replicas would have separate persistent volume claims unless you actually effectively did all that by hand again. Which didn't work for databases at all, because they all need read-write to their own storage. And there was no opportunity to reuse a persistent volume that was associated with a particular replica if that replica got terminated and brought up on another node. One of the ways we actually handled this was to do daemon set abuse, what we call daemon set abuse, where even though we have as a group of replicas, we treat it as a daemon set, and then you use host path to actually join to some sort of network storage, and therefore each node has access to its own claim on network storage, or to handle the volume management basically in the application. And I didn't even want to think about doing sharded Postgres under Kubernetes 1.2. This would just be a nightmare. Effectively you start looking, then you start saying, maybe this will be easier to do without Kubernetes. It would be, but now we have stateful set, and things are beautiful. So, our architecture diagram gets a lot simpler under stateful set for your single master Patroni Postgres, right? We need Kubernetes, and we need a distributed configuration management cluster, this instance etcd, and then we've got Postgres, a number of Postgres instances running the Patroni daemon. And they're communicating with etcd, and they're communicating with Kubernetes. And that's all that you need. So let's actually, because this will take a couple minutes to bring up. So I've got my etcd cluster up, but I do not have any Postgres up. So we're going to actually sort of start bringing that up while I actually explain what's in it. So there are, basically we've got 5 components here. We have, again, distributed configuration service cluster, the headless service that you need to create for every PetSet, and this is standard with PetSet, so I'll show you that in a minute, whether it be stateful set. A stateful set of replicas running Patroni. A master-only service at a minimum. You can also create a separate load balancing service for reads, depending on your use case. And then optionally, a persistent volume claim or persistent volume template, which is how you use it in stateful set, for storage, for durable storage for the databases. Now, the reason why I say that that's optional is that you don't always want it. And largely what that depends on is how big your databases are going to be. So, so if you have a large database, then you're going to definitely want persistent volumes, and you want to store that large database on persistent volumes so that you can actually reuse the data. And if you have a bunch of small databases, it's actually a lot easier to use ephemeral storage, that is node storage via empty dir. And big here is defined as how long does it take you to make a copy of the database via the replication protocol, right? If the answer is a very short time, if the answer is a couple of seconds, then you're easier creating lots of ephemeral copies. If the answer is an hour or more, then you're probably a lot better off using persistent volume claims. And that's just a, sort of application-specific decision. So let's actually show you that in terms of setup. So now, by the way, if you're having trouble seeing this on this, if you go to github.com, jberkus, atomicdb, the code is actually in there so you can get a closer look at it, but I'll show you this here. So, I mean, first we have to bring up an etcd cluster, and by the way, I don't know if you've looked at like doing this under a stateful set, but this made doing this particular action much less complicated. Like this is the entire business to bring up an etcd cluster that's using emptydir for node data. You know, we've got our headless service, which is a requirement of a PetSet. And, you know, so you create this headless service as a requirement of a PetSet. We've got our secrets, and then we have the actual pet, which is still a PetSet in the API. We've renamed it, but we haven't actually released a code version with the change. And so that's actually a good example also for if you have to bring up an etcd, a 3-node etcd cluster. The particular thing that we actually get out of this, out of stateful set, is when you do when we bring up a bunch of stateful set pods, as you'll see, our node names here are predictably incremental. And because they're predictably incremental, if I'm bringing up something like an etcd cluster, then I can actually give it an initial cluster configuration and pass that as an environment variable, so that it will just come up. Rather than, to show the counterexample, go to, I think CoreOS on their site has a pre-stateful set example, bring up a 3-node etcd cluster, and it's several pages long. Yes?
What if your control plane already has an etcd cluster?
I don't recommend using the etcd cluster that Kubernetes uses for its own management. I don't recommend using the same one for apps. Bring up a second one for apps. There's a couple of reasons for that. One is potentially performance, because if the etcd cluster is so busy Kubernetes can't ask it things, then your whole cluster is paralyzed. And the bigger one is security, right? I'm going to give you an example here. Actually, the etcd that Kubernetes is running on here is actually secured SSL, et cetera. And I've actually brought up this one for my demo here completely unsecured. So yeah. But that's etcd, and you came here to see Postgres. So we've got a couple of things for setting up Postgres, right? We've got, obviously you have to have some secrets. In a real production thing, I would actually be using probably HashiCorp Vault for these, for rotation, et cetera.
Secrets in Kubernetes?
Yeah, the thing is that secrets in Kubernetes are really not that secret. You know, I mean, they're base 64 encoded. There's a lot of ways to get to the information. There's no, you know, enforced rotation or anything like that. Something like Vault actually can do that, and one of the reasons I like to use Vault with Postgres is that Vault has a plugin for Postgres, so that I can actually enforce credential rotation and have it work inside Postgres. And then we have our cluster. And it's actually quite simple. So again, first of all, you create this headless service, right? We've got an API version. We've got our service here. These components are just labels to grab it. And so, and the important thing here is we're selecting off the labels that we've got on the items. And one of the things that's actually, I need to add a doc patch for, because it's there in the examples, but it's not documented. If you're actually creating the headless service for a PetSet, cluster IP has to be none. We don't get a cluster IP from that. And it will just mysteriously not work if you don't set that. And so then we've got our PetSet configuration here, right? And so we got our basic declaration, the labels, and that sort of thing. But part of it starts out, your PetSet starts out with, we've got a service name. And that service name needs to relate to needs to be the same as the headless service we just created. Well, it's better to do them in one go. The number of initial replicas that we have, template with metadata and a bunch of other things. And And here's our container version, and then here's a whole bunch of environment variables I'm passing in order to create Patroni's initial configuration, which includes things like it needs to know where to find etcd, it needs to know what cluster it's a member of, it needs to set some initial passwords and security information for Postgres, because otherwise you can't connect. And then I need to actually have some downward API information in order to do discovery, because the nodes need to not only be discoverable by the applications, but they need to discover each other. And so we need to pass that information, which is all available via the downward API. Patroni actually has 2 ports. 5432 is, you'll recognize, the Postgres port. Container port that's actually the Patroni API port, which is important because we need to be able to get information from that, and the nodes need to communicate with each other. And then some volume mounts for data, et cetera. And these I'm running ephemeral, because they come up a lot faster if I do that. So actually, you know what, I'm going to kill these again, because I want to show you another important thing about how stateful set works. So one of the things you'll notice with stateful set here is it actually, one of its features is it creates the nodes in numerical order. So those numbers that we're getting here, Patroni 0, Patroni 1, et cetera, those are assigned by the stateful set API. I didn't actually create those names. And so it'll bring them up there. Okay, and so we've got all of them up now. And so then the other question becomes, well, where's the master, right? Because part of this whole game is where's the master? And so one of the things, and this is something that I think Alex at Zalando figured out, is that in order to do all of this, oh, they're not finished coming up yet. Okay. Well, let's make sure we're not blowing up. Ah, that's why. Hold on just a moment. See, this is the problem with doing this multiple times. Actually, you know what? Because I killed it off and brought it back up, it's trying to reinitialize the same cluster, which it does not do in an automated way, because you could lose data if it reinitialized a cluster that had already been previously initialized. But that means that I actually need to kill off right. There we go. So in a couple of seconds, it should actually figure out that, there we go. It should figure out that there's no longer a leader. And so then when it figures out there's no longer a leader, it holds a leader election among the nodes. Now, when you're doing an initial deployment, if we hadn't had that initialized key blocking, it would always end up being node 0, because that one comes up first, right? But in this case, because we remove the key, it holds an election, and it's largely timing based. So if we actually look at this, so this is what Alex figured out, is that we can actually abuse Kubernetes annotations for our where's the master, instead of requiring an external proxy to do this. So this Patroni role tag doesn't exist when we do the initial deployment. And if you actually have a tag that doesn't exist when you do the initial deployment, then the individual application can use the service API in order to add tags that it owns. And that means that it can basically set which one's the master and which one's the replica. Now, once we've set which one's the master and which one's the replica, then we want the applications to connect to it, right? Because this headless service is really just for the nodes to communicate with each other. We can actually use it internally to communicate, but it's a lot better to create a separate service for the applications. So the read service is easy, because the read service is let's load balance among all of the nodes, right? The tricky one is the master service. And so the master service, we actually create this selector that grabs that role key. So it's actually, okay, we've actually already got those up and running. So, prove this works. I've got another container running with the Postgres client tools in there, and we've got PSQL here. So we should be able to connect. So this shows that we're actually on a writable node. The PG's in recovery is am I a replica? It's our cryptic way of saying am I a replica? So we're on a writable node here. Now, of course, this would be no fun if we can't actually manipulate this. So first, let's actually scale this, right? Oh, right. Resource name. So those will take a minute to come up. There we go. Actually, those are coming up really fast. So the new ones that come up, obviously, they come up as replicas, and they join the master as part of the replica set. They pull down a copy of the database. They start replication automatically, right? But then the other fun thing is that, of course, failover needs to work. Yes, good point. And so, oops, it's not what I want in my command history. So this will take a few seconds to actually realize that the master's gone and to hold a new leader election. The leader election operates in two stages, basically. First stage is standard leader election via the DCS to see who grabs the leader lock. Second stage is checking the replication status of each node to make sure that we're not electing a leader whose replication is broken or that's really far behind. There we go, and we have a new master. And the other thing that, should happen is that then node 1 gets replaced automatically by Patroni and then joins replication. So that's all working. It's pretty awesome, actually. There's a few small issues that I'm going to go over. But as far as automating single master Postgres is, now that we have stateful set, it basically just works. Now you can add extra refinements on it in a real production circumstance. I would actually want things like an actual connection proxy for the applications, and the connection proxy would plug into the service, and all of the other usual tooling. You need like a backup container to do automated backups and a bunch of other things. But for a basic setup of, hey, I just want HA Postgres, it now all just works, and Kubernetes makes it happen, which is awesome. Now there are a few things in this setup that are not ideal. One is if you're relying on DNS via Kubernetes services, if your application relies on persistent connections of some kind, or your connection pool relies on persistent connections, it's not necessarily going to behave well when we do have those failovers or when nodes get migrated. What? It depends on your implementation, on your reconnection implementation, and that is That is, anything that's a persistent connection is not going to look up the address well as long as it thinks it has a valid connection. So one of the things that can happen is you don't actually get a failure until somebody tries to send data. And then if it's a badly programmed proxy, like a lot of the Tomcat proxies I've seen, it may not try to reconnect in any intelligent way. It may try to reconnect to a cached connection, which is now wrong. So you may need to actually do some refactoring of your connection logic and applications for this to just work for you. And like PG Bouncer, a lot of people use PG Bouncer. When backends go away for PG Bouncer, because PG Bouncer is nice for scaling lots of connections for Postgres, but when backends go away for PG Bouncer, it tends to not try to replace them by lookup. It tends to just send you error messages, which is really annoying. Also, the built-in Kubernetes DNS is not necessarily super speedy compared to connecting like by IP address. So there is some extra lag in forming new connections, but it's worth it for the ease of management. Now, so what I'm working on right now is working on getting stateful set up with sharded Postgres, as well as multi-master synchronous replication. So, and I actually have to show off a demo of those next week. So at PGConf Silicon Valley. So I will, if you follow my blog or anything that sort of thing, you'll see those next week. Now there's some other things in Kubernetes to finish up here.
What was the third thing?
Oh, complex replication topologies. So I want to have some asynchronous replicas and some synchronous replicas and some cascading replicas. That's a big to-do in the Patroni world to actually support that in a meaningful way. I mean, you can kind of do it ad hoc, but it becomes a big management headache. And it is something with people with actual production implementations need to have.
And this is still reliant on the maturity of the persistent storage service in and of itself externally.
Yeah, well, it depends. I mean, obviously, if you're using a cloud host that supports dynamic persistent volume claims, then it works, right? We're still waiting for a lot of stuff, and I'll actually talk about some of that. So here's some of the other things we're waiting for. The affinity, anti-affinity, new affinity, anti-affinity stuff in 1.5, because we don't want to have multiple replicas from the same database on the same node, because then you don't have HA. Stateful set federation.
What's the issue with 1.4 again?
They're changing the affinity, anti-infinity API and sort of syntax. The stuff that we had before with the annotations was really hard to make simple rules like don't put two nodes from this stateful set on the same, two items from the stateful set on the same node. And it would often be ignored by the default scheduler, frankly. But that's all being fixed in 1.5. I understand there's work on stateful set federation to support general federation. You know, we have general federation in Kubernetes. Now I have to actually say, hey, I want 2 replicas in this data center and 2 replicas in this data center and 2 replicas in that data center. So one of the things that we don't have in Kubernetes in terms of compute reservation, in terms of saying, hey, you know, these are our compute nodes and you need to, you know, because affinity is really the wrong way to do this. Really, we should be able to, for things other than 2 shards from the same set, we should be able to say, hey, this needs this many IOPS and don't over-allocate storage for it. And we don't have that in Kubernetes, and having databases in Kubernetes are really showing that we kind of need that. Also, for persistent volumes, I want to be able to have more intelligent reclaim policies, because if a PVC has been idle for like 24 hours, I probably don't want to reclaim it. I probably want to spin up a new replica and copy off the master. And if the reason why it's failing is that the data is corrupted, I definitely don't want to reclaim it. Plus, for some storage types, I'd kind of like to be able to use host path, which means using things like subdirectories under host path, and we really can't do that without reclaim policies. And then for like a sort of complicated use case that I'm trying to enable is that for real production sharded Postgres, for every shard, you have 1 or more shadow shards that are ready to step in if the primary shard dies for some reason. Well, I need to, through stateful set, actually be able to assign those shadow shards and use them to replace the primary shards. And since I can't rename any of those stateful set instances, I can't really do that right now. But these are tweaks, and you know, we'll get there in some form. So I've got a whole set of resources for this. Actually, I have not pushed the current version of the presentation, but I'll do this right after that. Patroni, if you want an actual like production deployment of something like this, because this one that I have there, which is the code is up, but it's meant as a demo, so it's easily comprehensible. A production version would be like the Helm chart for Spilo, which is the production wrapper for Patroni, which has all of the other tools and components and sidecars and things. And but if you want to look at the demo, the more easily comprehensible demo, it's there on GitHub. So how much time do we have for questions? Yeah? Yeah? Okay, awesome. So here, so we get this on the, wait, how do I turn this on? Is there an on switch for this? Or is it just automatically on? Okay, go ahead.
So,
Yeah.
we're at a state where we could decide whether to use PetSets with Postgres or MariaDB or database, or go for a hosted database solution like RDS.
Yeah.
What's your take on what can we get from each one if we exclude optimizations and
Yeah.
secret sauces?
Well, I'm a Postgres guy, so I don't actually know a lot about MariaDB. So I don't really have an opinion on that. Versus RDS. RDS is extremely popular. When I was a Postgres consultant, we adminned a lot of RDS instances for our customers. But we still had to admin them. You know, as in our customers were still hiring us as consultants to admin their RDS instances. So I've never quite understood the appeal of RDS for that reason, but then I'm very much a do-it-yourself type guy. I would say that in the current state, like if you have an infrastructure based on Kubernetes 1.4 or later, that it's now gotten so easy to actually do this yourself that it's probably going to be easier for you to do it in Kubernetes than to do it via RDS. So if you want to, yeah, go ahead. Could you pass him the mic?
Okay, so just a quick answer because we're using RDS, so I'm from Zalando, and this Spilo project, we're running a lot of production databases on Docker with Patroni, not on Kubernetes yet. We are moving them to Kubernetes, so this will be interesting. But RDS, you don't have super user rights, you cannot use so not full admin access, you don't have logical replication, so a lot of cool features if you really want to use. For example, Postgres you cannot use with RDS.
What are the workloads currently running in production?
Yeah, next right here.
Sorry, I have a question. So, a couple of questions. In regard to persistent database connections, do you have an opinion on using PG Pool? Kubernetes it adds that extra hop, but it seems
Okay. So right. So first question was whether I have an opinion on using PG Pool, and I've been working on automating Postgres and Postgres HA failover for I don't know, like 5 years now, and part of this has been a quest to avoid PG Pool. So that's basically my opinion of it. Is the problem is that PG Pool tries to be the Swiss Army knife of like Postgres management. It's a connection manager and a cache and a replication manager and a query pre-parser and something else. And it means that it doesn't do any of those things particularly well. So I don't recommend using PG Pool. If you want a proxy to support your applications, I recommend PG Bouncer, which is much simpler. And I've been talking to the Crunchy data folks, and they're actually working on a new, much simpler Go-based proxy. That will probably be the thing to use once it's 1.0.
Gotcha. Another question I have with Patroni, does it automatically roll with the new Postgres versions, or so when we move from, like, say, 9.6.1 or 9.6.2?
The question is, does Patroni automatically move with new Postgres versions, or both updates and the new versions? This is two different questions. It does not automatically move with updates, but the thing is, because failover is automatic, what you do is you use a Kubernetes rolling upgrade to upgrade the containers to the new version of Postgres, and failover will happen as you do the rolling upgrade. And then doing major upgrades, that's waiting for Postgres 10. After Postgres 10, you'll be able to do major upgrades via replication. You can't right now. Okay, so we had a question over here.
How serious is this? How seriously what kind of workloads are being deployed? There is a view that running databases on Kubernetes is a unicorn.
Yeah.
It's not going to happen. It's not for serious workloads. Like, how significant is this?
Right. So the question is, what sort of real production workloads are being run on this? Because a lot of people don't think that you should run databases on Kubernetes or in containers, et cetera. Well, in terms of like the major production workload, I'll let the gentleman from Zalando, although he's not running it, they're not running under Kubernetes right now, but they're definitely planning to.
Yeah,
That's why they're doing the work.
So we are running everything in Docker already, but one-to-one with EC2 instances. So we will have dedicated node pools on Kubernetes, and we'll definitely move everything to Kubernetes. And that's a few hundred databases. We are huge Postgres fanboys, so we are not on Kubernetes right now in production, but probably for KubeCon in March, we'll definitely have a lot of experience to talk about.
Yeah.
But we are already running in Docker and so on. So it's,
Yeah.
Yes.
Yeah. And
Running on Postgres.
They're running in Postgres in Docker on AWS with Patroni,
Yeah.
with a Spilo, but not on Kubernetes.
Yeah.
So it's not so different, but then we'll move it
Yeah.
to Kubernetes.
So you're using EBS for it?
Yes, EBS.
Yes.
And what's the size, like, give us a sense of size and scale?
Oh, I don't know. There's like a
Yeah.
few terabytes in total, but
okay, are we out of time now? No, we got 3 more minutes. So take one more question here.
How do operators influence like the use of PetSets and this sort of setup that you're trying to create?
How do you operationalize the use of PetSets?
Operators, Koros recently released operators where they do this for, try to automate this for etcd and Prometheus, and well, those are the 2 that they already created. I don't know if it's fairly recently announced.
I'm not following the question. The maybe it's just because I didn't see that announcement. So
Last Thursday, Chorus did a blog about operators.
okay.
Managing applications or applications.
See, the operators I know are greater than, less than, between. So I don't know. I did not see that release, and so I don't have an opinion on it. If they can do etcd with it, we can probably do Postgres with it. So whatever it is. So one last question.
Could you maybe
Yep.
Could you maybe talk about how what you're doing compares with what CrunchyDB is doing and kind of the differences or what the goals are?
So the question is what they already did versus what they're doing now. So the CrunchyDB reference deployment for Postgres was built to work around the limitations, I think, of actually Kubernetes 1.1. And so you'll see their diagram, I don't have it up here, but there's actually like 11 different kinds of containers, a lot of which are sort of internal management containers and proxies, and they've got PG pool in the mix and that sort of thing. And a lot of it is because we couldn't do this stuff, right? We couldn't manipulate the Kubernetes DNS to redirect it to the master and do all of these other things. One of the things with stateful sets, et cetera, particularly once 1.4 is supported with OpenShift, they'll be able to simplify their architecture based on using a lot of the same techniques. I think they haven't decided yet whether they want to use, there are several daemons that are similar to Patroni, and I don't think they've decided yet whether they want to use Patroni or one of the others.
Yeah, it seems like they actually have a story in a container for the backup and recovery too, right?
Yeah, and you would need that under this too, right? Because you need something to run PG dump or to run a PITR client or whatever.
So that's my question, like why has that not been included in this? Why not?
Well, because I'm just doing a demo. I mean, a production one, like I said, look at Spilo and you've got all of these things.
That part's pretty complex.
Yeah. So you know that would be included in this and that sort of thing. It's the core failover and connection management that's getting simpler. Everything else is pretty much the same. Okay, and now we actually need to go. So if you have people with more questions, I'm happy to take them out in the hall. Thank you very much.